Okay, so in this particular video, I'll do a couple of fundamental beginning average speed problems, just so you can kind of see how the speed function is played with, okay? All right, so let's do this. So in the first example here, you have a car moving at a constant rate, aka constant speed of 30 miles per hour. It is noted as mi divided by h, or you can say mph, which is the accepted shorthand for miles per hour. And then it says that it's going to cover point A to B, which is a distance of 160 feet. Okay, so the question asks us how much time would it take for the car here to cover this much ground. So let's go ahead and knock it out. The first thing you should notice is that the unit for speed is in miles per hour. However, the unit for distance is in feet. So miles and feet are two different units. So I encourage you to make sure that they're all the same units of length before you proceed. So I'll go ahead and convert 160 feet to miles. So to convert 160 feet, start with 160 feet, and then the ratio for miles and feet is given at the very end of the problem there, which is 1 mile has 5,280 feet. So instead of feet to start your problem, because you don't want feet, you want to put that unit of feet in the denominator in the first fraction there. So the unit for feet will cancel out. And then for every 1 mile, you have 5,280 feet. Make sure you pay attention to where you put these values. Don't flip them, okay? So if you punch in your calculator, you should get about 0.0303 miles. Notice here I just kept the decimals to the fourth place just because the value is so small, I didn't want to round it too much, okay? All right, so feet cancels out, and you're left with miles. The function for average speed is simply distance over time. In this particular question, it asks us to find time. So I like to point out that t here is in the denominator. So to solve for a variable, or to isolate for it, you have to get that variable in the numerator. So we have to somehow get this t to be in the numerator. So I'll just do this. There's different ways to do it, but I'll just do this. I'll multiply both sides by t, just to bring it up to the numerator on the left side of the equal sign. And so therefore the t's on the right side will cancel, and you're left with this statement. So t times average speed is equal to distance. But because you want to solve for t, you have to get rid of average speed. So to do that, you would just simply divide both sides by average speed. You want to divide because that's the opposite operation of multiply. So average speed on the left side will cancel out, or just reduce down to 1. And then you would do the same on the right side. So time is equal to distance divided by average speed. So from there, we can just plug in values. We know our distance that we converted is 0.0303 miles. And then the unit or the value for average speed is given to us in the statement, which is 30 miles per hour. But here I just chose to write it miles per hour in this unit, so you can kind of see how if you do it right, units will cancel out. So the miles on top is going to cancel with the miles on the bottom. Therefore, the only unit that is left over is hours. So right now we have that the time is equal to 0.00101 hour. But the question didn't ask for time in units of hour. It asked for times in units of minutes. So all we have to do really here is just convert hours to minute. So we have to do one more conversion step. Start with the hour here, and then because you start with hour, the next unit that goes in the denominator in the first fraction or conversion factor would be hour, and that'll cancel out. And then for every 1 hour, there are 60 minutes. So if you do this properly, you should get 0.0606 minute. So that's the first example. Okay, let's move on to the second. Again, these are fundamental average speed problems. Here we have a dolphin that can swim at a speed of 30 kilometers per hour. And the question asks how far, aka distance, has the dolphin travel after 5 hours. But you notice here that it asks us for distance in miles, and here the speed is given in kilometers per hour. So these are things hopefully you'll pick up as you practice problems. Sometimes you need to convert, sometimes you don't. For this one, I can see that I need to convert because the unit for miles, or for length in this case, is kilometers. But the question asks us to give our answers in miles. So I know right away I need to do some sort of conversion. So for this one, I'll go ahead and just start out with average speed equals distance over time again. The question is asking for distance, so I have to get d by itself. So the d right now is already in the numerator on the right side. So to get d by itself, I need to get rid of this t in the denominator. So to get rid of t, I would multiply both sides by t again similar to the previous example. By doing that, I can cancel out the t in the denominator on the right side. But don't forget, what you do on one side, you have to do on both sides of the equation. So here we have distance is equal to time multiplied by average speed. And we know both those quantities. Both those quantities given to us in the statement. Time is 5 hours, so we can plug that in. And then the average speed for the dolphin is given in the statement in the schematic here, which is 30 kilometers per hour. And then if you set things up properly, the unit will cancel out, the unit h will cancel out. And then here we can just multiply 5 times 30 is 150, and the only unit left over is kilometers. But again, pay attention to what unit is asked of you. In this case, it asks us to express our answers in miles. So we're not quite done yet. So the last step would just simply be convert this 150 kilometers to miles. So here I have 150 kilometers to start, and then kilometers going to go in the bottom of the next conversion step, so that cancels out. And then for every 1 mile, there's 1.61 kilometers, which is given at the very end of the statements here. Okay, so if you do that properly, the unit for kilometers will cancel out. So you would have 150 times 1, which is 150, and then 150 divided by 1.61 would give you an answer of about 93.17 miles. Okay, I hope that helps in terms of just kind of rearranging the function just to kind of start. All right, stay nerdy, don't be wild.